Assalamualaikum warahmatullahi wabarakatuh. And hi everyone, my name is Melo Adina binti Zulkarnain. Today, we would like to present to you about practical work generate skill topic 2, diode for semiconductor devices. Then we go to the first one. What is diode? Diode is used for converting alternating current to direct current, DC current, which is as a rectifier. Diode allow current to flow easily in one direction, but severely restrict current from flowing in the opposite direction. Diodes are rated according to their type, voltage, and current capacity. There is several types of diode, which is light emitting diode, LED. LED is a transducer which converts electrical energy to light. It can operate with either AC or DC. LEDs require to DC supply of the correct electrical polarity. Then I will explain about laser diode. A laser diode is a laser where the active medium is a semiconductor similar to that found in a light emitting diode. Application used in various measuring instruments such as range finders. Then there's also a diode which is called signal diode and varactor diode. Next, how do we decide diode polarity? How do we know which is anode and cathode? First, we need to reverse the multimeter probe. Second, using the multimeter, ohms range stand, check the diode's continuity and determine its terminal, which is anode or cathode. As we can see from the diagram, we can see there's several types of diode, and we can see the anode and cathode.
Hi, my name is Nurul Shahada binti Abdullah. My matrix number is 01DE24F1092. Today I'm going to explain the working principle of half-wave and full-wave rectifier. A rectifier is an electronic device that converts alternating current to direct current. First, I'm going to explain the half-wave rectifier. A half-wave rectifier only allows one half of the AC waveform to pass through, blocking the other half. This result is a pulsating DC output. The working principle is when the AC supply is positive, the diode is forward biased, allowing current to pass through the load. Then, when the AC supply is negative, the diode is reverse biased, blocking the current. Lastly, this produces an output waveform with only the positive half of the AC cycle. Second, I'm going to explain full wave rectifier. A full wave rectifier converts both half of the AC waveform into pulsating DC using either two diodes with a center tape transformer or 4 diode in a bridge configuration. The working principle is during the positive half circle, one set of diode conduce, allowing current to flow in one direction. Then, during the negative half circle, the other set of diode conduce, inverting the polarity of the current so it continues to flow in the same direction. Then I'm going to demonstrate how the diode allows current to flow in one direction and convert AC to DC. I'm going to explain it step by step. First, AC input. Alternating current continuously reverse direction. It has positive and negative cycles. Second, diode functionality. The diode acts as a one-way valve for alternating. When AC is positive, the diode is forward biased and allows current to flow. When AC is negative, the diode is reverse biased and block current. Third, the rectified output. This result is a pulsating DC voltage. Only the positive cycle pass through. Then I'm gonna explain the demonstration. If you have a diode, a resistor, and an oscilloscope, you can first connect the diode and resistor to AC power source. Second, observe the voltage waveform before and after the diode. Third, you will see the negative cycles are removed, resulting in pulsating DC. Then I'm going to explain the comparison the output waveform of half-wave and full-wave rectifier. The output waveform of half-wave and full-wave rectifier differ significantly in terms of shape, efficiency, and ripple frequency. First, I'm going to explain the half-wave rectifier output waveform. First, the diode only allows one half of the AC circle to pass, blocking the other half. Second, this results in cap in the waveform during the negative half circle. Third, the output voltage consists of pulsating DC but with less ripple. Fourth, ripple frequency is equal to the AC supply frequency. Second, full wave rectifier output waveform. First, both half of the AC circuit are converted into positive poles. 2. No gate exists. Instead, the negative cycle are filled and apply in phase with the positive cycles. Third, the output voltage is more continuous, reducing rip contents. 4. Ripple frequency is twice the AC supply frequency, making filtering easier. Resistor. The function is control current flow and voltage drop in circuit. Use in rectifier. Act as a load resistor to receive AC output. Then it help in voltage division when required. Third is power supply. The function is provides electrical energy to the circuit. Use in rectifier, AC source like main power provide the alternating signal. Second, the voltage levels vary depending on rectifier design. 4 is the oscilloscope. The function is visual display voltage waveform. The use in rectifiers help observe AC input and rectifier DC output to ensure the variation and ripple effect in rectifier circuit. 5. The signal generator. The function is generate AC waveform for testing circuit. The use in rectifier provide adjustable frequency AC input. Then useful for testing how rectifier respond to different signals. Then I'm gonna demonstrate how to measure the output and observe waveform change. Measure the output of rectifier and observing waveform change require an oscilloscope and multimeter. First, set up the circuit. Use a rectifier circuit connect to an AC power supply. Then connect the load resistor to complete the circuit. Second, measuring DC output with a multimeter. Set the multimeter to DC voltage mode. Then connect the red probe to the positive terminal of the load and the black probe to the ground. Then observe the voltage reading. The half wave rectifier should show a lower DC voltage, and the full wave rectifier should show a higher DC voltage due to continuous conduction. Third, observing the waveform using an oscilloscope. Set the oscilloscope to AC mode for waveform visualization. Then one probe at the rectifier output and ground probe to the circuit ground. Then observe the waveform. The half wave rectifier, only positive circuit are visible with gap in between, and the full waveform rectifier, but half are converted, showing continuous path. Then lastly, apply filtering. Add a capacitor across the load to smooth the waveform. The oscilloscope should now display a more stable DC voltage. And that's all for me for rectifier circuit explanation and experimental procedure. Thank you.